Okay, so today we're going to talk about another type of probability, and it's called permutations. It has to do with the order of the objects that we are finding the probability of something happening. So what exactly is a permutation? When the objects in a sample space are arranged so that the order is important. Permutations have to do with order. Each possible arrangement is called a permutation. So if you look at these bats here below, they are to represent each batter and the order in which they are going to bat. So person A is first, then B, then C, then D. Or person A is first, then D, then C, then B. Or person D is first, then B, then C, then A. And the order in which they bat matters. I don't know how much you know about baseball, but you want your best hitter to be the fourth, because then they can hit a home run and get everybody home. So using the fundamental counting principle, we can find the total number of permutations, or the total number of options of order. So the choices for the first batter would be 4. There's 4 different people that we can have in the first position. Once the first position is chosen, the second batter only has 3 possible choices. Then the third batter has 2 possible choices left over, and finally, whoever's left over is the last batter. So 4 times 3 times 2 times 1 will give you 24. Now, as if this is not all confusing enough, we have another new thing. It's called a factorial. Now, this is actually nice because it's going to make your life easier to do math. So a factorial is 4 exclamation point. I bet you didn't think that an exclamation point had to do with math, but it does. Okay? So the explanation point means that we're actually doing 4 times 2, not 2, 3 times 2 times 1. We're multiplying each number less than 4 by itself. So what do you think 6 factorial means? Well, it means 6 times 5 times 4 times 3 times 2 times 1. So how do we use this new math operation? Well, you can perform a factorial by choosing the math button on your graphing calculator and then going over to the probability menu and then choosing option number 4. Now, that will put the exclamation point in there. So you need to make sure you type the number first and then go through the process. So if I were to find 6 factorial, I should get an answer of 720. That's the same as 6 times 5 times 4 times 3 times 2 times 1, which is also 720. Hopefully you went through and tried all that in your calculator just now. Okay, so let's talk about these permutations now. Here's some examples. Shaquille has a 4-digit passcode to access his email account. The code is made up of even digits, 2, 4, 6, and 8. Each digit can be used only once. How many different passcodes could Shaquille have? So you notice here the order would be important. The password 2468 is different than the password 8462. Okay, so we have 4 possibilities. So the answer is 4 factorial, which gives us 24 possible codes using those 4 digits in any order. All right, try the second one. Jaime, Shana, Otis, Abigail, and Ernesto are lining up to take a picture on the beach. How many different ways can they line up next to each other? So we have 1, 2, 3, 4, 5 different people that we want to put in different orders. Okay, so we are going to have an answer of 5 factorial, which gives us an answer of 120 different ways that this photo could be taken. Bet you didn't realize there were so many choices when you were taking a photo of how to line up. Okay, so there are more complicated permutation problems, and we'll get into the difference here in a minute. It'll be really easy for you to see. So this formula here is what is going to help you when we're doing this problem. N is the number of objects, and R is how many at a time you're going to use. So sometimes when we have a code, we have the option of the numbers 1 through 10, but we don't need to use all the numbers. So we've got a word processing program requires a user to enter a 5-digit registration code made up of the digits 1 through 7. No digit can be used more than once, and that's really important. If digits could be used more than once, it would change our answer. It would not be a permutation. So, using this formula here, 7 is the number of objects. We have 1, 2, 3, 4, 5, 6, 7. Those are the possible numbers that we can use. But we only need to use 5 of them. So that's how many we're using at a time. So now that we know what N and R are, we just have to plug it into our formula. So instead of N, I write 7 factorial. And then on the bottom, I'm doing 7 minus 5 factorial. So that's 7 factorial divided by 2 factorial. And then we just have to put that in our calculator and find out what the math is. The answer is 2,520 different codes that we can do. All right, let's try one more. Oh, and by the way, yes, I will give you this formula on the quiz or the exam. So the addresses of the houses on Bridget Street each have 4 digits, and no digit is used more than once. If each address is made up from the digits 0 through 9, how many different addresses are possible? So what do you think N is? What do you think R is? N, remember, is the number of objects. How many possible objects can we use? 10 of them. How many are we going to use at a time? 4 of them. So now we need to fill in the formula. 10 factorial divided by 10 minus 4 factorial. So that's 10 factorial divided by 6 factorial. Now just plug it in the calculator and do the math. That gives us a total of 5,040 different possible combinations of addresses. Okay, so for homework, I've got 5 problems here. They're numbered very strangely, 1, 11, 25, example 2, and 4. Label them that way. That's how I found the problems. So good luck. Make sure you take a look at the difference between a permutation where you just do the factorial and a permutation where you need to know the number of total objects and the number at a time. See if you can see the difference.